Mm, mm, mm. Hello, hello, hello. Welcome, welcome to stream. How's y'all nights doing? Hopefully they're good. All right. So today I want to continue the frame graph or the rendering graph. Um, and yeah, getting into some funky implementation stuff. So let's see. Pretty much how it feels. Um, okay, let me close that. And we can get the thingamabobber up. There we go. There we go. The good stuff. So we had our graph.ofg, which just means ocean frame graph. A little semi-custom file type. And then if I remember correctly, we have it so that it's already finding by name, it's already recording the keys. And I can technically find by name already. Which is nice. And what I want to do is figure out how to store the data as more of a tree. Let's open this up. Ooh, it's bright. I'm sorry. Because we have an example graph there. Right now, we basically just have a list of data points that just kind of exist, right? So we have like our graph. And then we have the passes. This is probably more work than I need to, but that's okay. I enjoy it. Because now we have like the name. And then, it's the inputs and then the outputs and all that stuff, right? Right now, it's just a list, which is cool and all, but it's not helpful in terms of how it's stored to make it so it's easy to do, say like, oh, the paths contain a list of names and inputs and all that. So what I want to do is figure out how to do basically group keys together. So like we have an input that has a name and a type attachment, and these should be grouped together because they are both within the brackets. They are one element. I want to do that because then the same thing for the outputs. Then we can do a group that is a name, type, format, resolution, and operation, where it is all together in a nice format. Hopefully that makes sense. Yeah, there we go. Because then we can say that it is not like that. It is, we have our outputs, which then is a group that is technically in the passes. And that's the goal. Because then the inputs and outputs are going to have elements that are within the containment. So then it'll be like that, and then it'll be like types, and then we have our outputs after that. Basically, we want to have depth control in the data, because it just makes it easier. Which means we want to have it be that a node essentially, like, because right now we have a type, OFT type. And what we want to do is make it, excuse me, make it so that a node is all of these sorry. A node is the level that it lives on. Or like a node is one element. So in this case, it is a element of one graph that has one passes because they are grouped together. There are two components that are at the top level. And I think that would work. Oh, let me get that to the wrong other thing. Reply. Okay. Bom, 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 bom. It's going. Okay. So that is what we're trying to do with the data, which is hard-ish. So that means we are templating items that we don't know if they exist. And I think what we're going to end up doing is having to do I think what's ends up going to be happening is I'm going to have to make my nodes based off index so that it is all contained within an array so that it is linear and not a lot of memory jumping, which is going to be faster. Because the problem with it otherwise. Okay. What I'm going to do is I'm going to create a class that is OFG data. Because I want to not have this be attached to the file, because all the file does is it just basically gets the data and puts in a clean string. Oh, shut up, Xbox. No, that was the wrong one. Stop. No. Xbox might open because it's stupid and bad and dumb. Okay. That's kind of what it's going to end up being. Inline car pointer data. Data. Basically that. Not even to the point of like nodes yet, because we need to just get the data loaded correctly. What I'm gonna do. I'm going to take this and I'm going to move. Let's see, Mantic, do you have something? No. Basically, I'm going to create a OFG file.hpp. Pragma wants all that pizzazz. Create matching source file. And then under include. No. Ugh. Okay. Now it created everything to the best of its abilities. No pointer and 0. Okay, got that. Um, and this is no longer really a function of the file. Cool. Basically all it is. And then when it's destroyed, I want to delete the data, the P data. Cool. All right. I want to create a OFG data.hpp pragma once. For now, I can take basically this one. And then I can include the OFG file.hpp. So now I have a file that I can use. Mm-hmm. And then I'm going to have to create a class OFG ref. Basically a reference to data in the OFG data. I'm going to have to move that out for now. OFG ref. And this will take in, I guess, basically an OFG data. This is the fun part. Yeah, I don't want to do that because I want the reference basically to just look at the original data. So it views. So I guess I could say that it has a private, right? And then it has a constant vector of OFG types reference. So M data. And then it will have a size t of the m min and the m max or something. Something like that. Mm-hmm. Given the data, then basically this will have to be a friend class. So this would be a friend class of gref. Then I can say data.mtypes. There we go. Something like that. We'll see. We'll figure it out. And then OFG data. Constant car pointer car const ref is equal to file.data. File.size. This should be probably just data. Okay. That's done with. Okay. And then we want is and this can be just a file now. Because it knows nothing about the actual type. File.hpp. File.cpp. Okay, that's all done. Easy. Now it just takes in the file. So that's relations, and then I want the private functions. Is stop car C. Cool. Frame graph. All right. This will probably work differently, but for now. Yeah, I'll just get rid of that because I don't need that right now. Build, it should build. No. Clean rebuild all. Nope. Why is it being stupid? Recache it. Yeah, there it goes. Pretty easy. Now it's a lot simpler to work with. And now we are just handling data specifically and abstractedly where we just want to support this file type, basically. So let me just write a little bit. Okay. So, OFG file type rules. One, so a key always starts with a hashtag. And then another rule would be the following character after a key is always the control character. Okay. So now we can say for a control character, let me add spaces because then I can have like X. The following character after a key is always the control character. And so we have, if the character is a colon, then the following is the data. Or I guess then the immediate data. Oof. The immediately following data is. Oof. Trying to figure out how to say this right. Sure. Spelled right enough. If the character is a opening bracket, then the following data is a list composed of then the following data is a list. And then there's two rules that I want to make for this, because if the ending bracket is not after a repeated key, then the list is absolute data. And what I mean by that is it's absolute data as in, so like for the resolution, it is absolutely 1280 and 800. But when you're looking at the outputs, it is not absolute. You cannot say that it is an absolute piece of data because it has multiple keys within it. So like a name, a type, a format, a resolution, these are all absolute data. This is all absolute data, but they compose a complex data, essentially. An explanation, i.e. the data does not contain, should not contain any subkeys. Because now, if the ending bracket is try to make that clear, is after a repeated key, then the list is The list is composed data. I.e., the data has subkeys defining components. Cool. And then I also need to say if the character is a opening bracket, then the following information composes a single type element. Cool. One second. What? Oreo. Okay, I'm on stream. Okay. Okay. Thank you. All right. Sorry about that. All right, I'm back. And then I'll add the opening bracket, the character should always match with a cool. And that's really all that really is all the control keys. Because a comma isn't really necessary because we have the brackets and we know what level the bracket is. So we kind of don't care about that. The commas we can skip over. Basically, as long as they don't muddle. I guess. If the character is a comma and this is actually a should only apply in this case. If the character is a comma, then the list element has ended and a new one has begun. That's pretty easy. And honestly, I'd say that's pretty much everything that's needed. Okay, that's a custom data type language right there. That's all that's really needed because everything else can be figured out from that. Hmm. All right. Easy. Done. Going for it. I think this covers everything. I don't know, chat. We'll have to see. Um, I don't know what to call this really. Is it OFG data though? Or is it an OFG file? I'm gonna keep it at OFG data though. I'll have to probably make some kind of primitive. That's just a template that can be whatever. Okay. I don't think I really need that. Because I have to change the way that this is read, essentially. I was basically just going to run through the whole list of characters. Okay. Nice. Easy enough. Oh my goodness. All right. We'll be back. Ugh. All right, losers, I'm back. Sorry about that. I was being delivered ice cream. Or Frio. I guess it's technically not ice cream. It's somewhere in between. I don't know what it is. But it's good. And it's tasty. As it should be. Okay. Hmm. Yep. We got Husky. I think what I'm going to end up having to do is I'm just going to have to hash things. Theoretically. Well, no, I need to keep the key string. Well, no, I can hash it because a key, a pointer to a constant key will always be this correct. Oh, shoot. Wrong one. The real tastes like hot dogs. I don't know how the fuck they did it. It tastes like Frank's hot dogs. It's supposed to be Oreo. Like, what the fuck? It's not right. It's just not right. Ow. My ears are ringing. Okay. Hash a string. Let's see. What? How does this work? I guess I should say C because I don't really want. I want to figure out how it works. Mm-hmm. Okay. Oh. So here's a common way that the function hash is actually calculated, where it basically just says for each letter of S, so the string, it'll take the class function. Oh. Okay. Oh, they have dark mode. That's so nice. I'm gonna light mode. Sorry, but flashbang fuckers. Oh yeah. Here's an example of calculating a hash of string. Okay. Hmm. What is the Rabin carp? Oh, string matching. Mm-hmm. If we compare a string of S with 10 to the 6 stat different strings, probably at least one condition happens and now then. Hmm. Ten to the power of 6. Okay, so about 1,000,000 strings. I think this will be fine without caring about that. Up, LinkedIn. um, excuse me. Yeah, okay. So compute hash. Given a string. Hmm. I don't know if I need 10 to the 9th plus 9. Okay. So what I'm doing is some funky magic. Where now I can say hash or get an integer. Hash key, and then it gets a constant car pointer const key, because it gets the original, because then it gets the pointer, a constant pointer, so it can't change the pointer, and then it's a constant after the pointer to say it's constant data, so you can't change the data. Okay, that was easy. So now I want the constant expression. I could call it a constant expression. Okay. So I want a constant expression. Constant expression just means that it tries to make the expression const and it solves it at compile time. Or tries to optimize it at least, like heavily. And so in a lot of cases it's similar to a template class or a template function, but just based on what it's used, on how it's used. Okay, so say we want an int, an unsigned int p, which is equal to, what did they have p equal to? 31. We want it to be 53. The Frio still tastes like a hot dog to me. It's the weirdest shit ever. Okay, then m is just a large number, which can be equal to 2 to the power of 32. All right, upwards caret is an operator. Okay. Number is the 8th percent of prime equal to 2 to the 31st minus 1. Primality of this number was proven by Euler, reported proof in the letter. Euler used trial division, improving on most 700. 372 divisions we need. Cool. Don't need to know that anymore. Okay. There we go. Yeah. And then basically we just want a unsigned int, which is the value which can be equal to 0. And then while key at I is not equal to a null termination character, then we can actually do the hash thing. Okay. Then it's just I plus plus down here. And then you can just say that the hash value that the value is appended key at I minus a plus 1, so that we don't just add 0 and then the value is modulo to n. That's basically the entire thing, I think. I plus there. And it increments as it does it. So now it is a constant int, which is equal to 0 by default. Okay. And now this isn't really needed, which is good. Removing functionality from structs, which is what you want in C++. The structs are a form of data, and they should not have a lot of defined functions themselves unless it's very small helper functions. So now this is kind of going to be the most it's not, we don't want to set stack. Basically a stack of unsigned ints. It's going. We are so going. All right. The stack of keys because we want to make sure that we go through the right depth. Is it a stack though? I don't think it is. I don't know. I'm trying to think of when we... Well, I'm in the wrong thing. Whoops. Okay, when we go through basically the file, how do we organize this? That's the hard part. I could just make a 2D array, but that's not very, like, that's not very efficient. Because that's a lot of looking around in memory, which isn't fast. And really slow, which is kind of not what has happened so far. Okay. Okay. I guess I want to make a tree. I guess basically this is an OFG key. won't worry about the reference right now because that's not helpful yet. Oh, excuse me. Mm-hmm. Yeah. Mm-hmm. Okay. Trying to think. It's been a long day. Math is rough. I spent like 2 hours doing a problem just for the professor to say that the homework source was wrong about how we should do the problem. So that was my morning or afternoon. Okay. We go through all that. I want to know how I can represent this correctly. Hmm. The hash works, or should work. Why is P not being used? I just realized that. I'm just going to multiply by p. It was a little bit easier for now. That kind of makes sense. I think I'm gonna make it so that this is all in one line. Because then also theoretically should never. I see why it's value plus then here. Basically if data I is a character or a hashtag, then I want to yeah, basically I have to create a string I'll just use the standard string for now. Key and then basically while data at plus plus I is control character. Then I can just do a switch case on C, where if the case is that it is a colon, or if it is a opening bracket, closing bracket, or one of those, and then return true. Otherwise, it will return false. Easy control flow of that. Data at I. Push back. Okay. Don't really care about memory efficiency there. It's whatever. Then I want to take C out. Received. Received the key. Key. Hashed to hash key dot C string, basically. Cool. That all works. OFG data, given the file. OFG. Data file. Something like that. Okay. That looks all good. Cool. That's all working as it should, basically. Or data at I is equal to the space because we don't want spaces either. It's not equal to that. That's what it should be. Sorry. There we go. Now everything's a little bit nicer numbers. Yeah. Hmm. Mm-hmm. Still tastes like hot dogs. The real juice tastes like hot dogs, and it's concerning. Hmm. Okay. Yum 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 yum. Mm-hmm. Interesting. Okay. Um, I think I have to make a OFG element, right? Which is then going to be the OFG key parent key, because we want to know what the parent is, so that we can say that this is owned by, so say that a render pass is owned by the passes, essentially. Yeah. Okay. We're going. Okay. This should be called a hash because that's what it is. Then I'll type this to be a OFG hash. Cool. Then it's a little bit more clear what it is technically, but it's also technically hiding things, and so it's debatable, but I think it's good because it is saying this is being handled as a type and not as just an integer. Yeah, it's an element, the parent key, and then I guess it's going to be a vector of the OFG keys, which is the children. So like an element is this, right? And its parent is passes, and you want to know that its children is the name, the inputs, and the outputs, basically. That's hard. Because then you get into multi-level elements, because you have something like this where technically this is a set of two elements, or like two children, because it's 2 points of data that are owned by resolution. Let me pull up the YAML. YAML CPP. There we go. Too far. We could look at some of this. Hmm. Yeah. This is where it gets funky and complex. Um, hmm. Cool. Just trying to look at what there is. I think this one is just a binary handler, essentially. Yeah. Mm-hmm. We got the node. Sorry, this is probably hard to read. M. Oh, that's so bright. Y. Mm-hmm. Yeah. A lot of it kind of gets mixed together, it seems, because the testing is also uploaded. Mm-hmm. Yeah, basically, we're basically building a tokenizer. Okay. I forgot that that's what we're basically doing. Mm-hmm. Mm-hmm. Um, okay. Tokenizing a string. So back to this one. Yeah. So basically what what the tokenizer does is it converts a bunch of keys, right? Or it converts a bunch of keys into tokens, or like a hash, right? Or I should say OFG token. That's what it is. Because it's the parent and the children. As we look back at this thing, well, hide that. We want to be able to store everything into a depth related graph, or like a depth related tree. Which means these tokens are above. The passes is the parent token to name inputs and outputs. Right? Which is also one element. Because a graph and passes is an element. Okay. I think I know what I'm going to do now. An element is just a list of children. Right? So it is a list of graph tokens. So an element is graph and passes because that is all the on the same level. And name inputs and outputs is all one element because it is in the same level. Alrighty. Back from that. 10 more minutes and maybe a little bit of gaming. It's been a lot of thunking so far tonight. But yeah. So we got the graph passes, that's one element. Yeah, screw the whole thing. I don't care about that. I care about this. Because we have a list of children, which is an element. Yeah. Yeah. Token, which is just a hash. The element, which is a list of children. Tokens, basically. I think that's kind of all that's necessary. Because then because now we know that this key exists, right? Now we're just getting into actual control flow of reading the document. Because now we want to know basically where to put the key. Okay. An element has children tokens. Okay. So now I want a OFG, say, what should the variable be called? Chat? I guess it would just be a node, essentially, where then it is a basically it is a list of it's a list of elements. A node is a list of elements. So in this case, it would be the first, oh my gosh. The first node would be a list of elements. So it is just, so it would only be this element is the root node because there's only one. But if I were to say I wanted another frame graph in the same file, I could put it over here and then there would be two elements at the root level. Then we have the elements. And then we want a list of children nodes, basically. Yeah. So now this would be two elements. And then we'd have one element. And then we'd have one element, two elements, whatever. Because then we could also have, in this case, like here, this is 1, 2, 3, and 4 elements. And then if I wanted to go further, I could store the type of element. Because an element is defined essentially by, or I could define the type of token. Because that would tell me essentially what kind of data I'm reading when I look at that token. Because then I can say it's a string token or like a string token, a blob token, or a list token, which would be interesting. So I'm going to do that as well. So I'm going to say basically enum or type def enum OFG token type. And now I can say, well, I guess I should call it a absolute. And then a list, or yeah, that's basically what it is I'm determining if it's absolute or well, I could say if it's absolute or composed. Um, hmm. I'll just try absolute versus composed right now, basically. I'd imagine different ones are going to be wanted later. I'll do a undetermined is equal is 0. Mm-hmm. Because now what I can do I can say, I can basically just make a function, upper function that says bool is absolute, where I give it a constant car pointer const. Data, and I can say it's const. Where basically I can say while for an int I is equal to 0. Although up here it's feisty, but that's okay. Well, I can just say while data at while data, while the reference data, so it is the value at that pointer, is not equal to basically I have to go through is control car data. This can be marked const. Not changing anything. I do want to change the pointer. But I really shouldn't, so I'm not gonna. I is equal to 0, so then data at I plus plus. That's basically all I need to do because I want to hit the next control car. And then I can say basically if data at I is equal to it will be absolute if it is a colon. And then basically else then we hit I'm gonna do a switch case on this because it's gonna make it easier for me. I, and then I'll just copy the cases from up here. Basically, if it's colon, then return true. And then if it's any of these, return a false, because that means that these are all composed. And then this is the special case where I have to go until the next hashtag. So while basically data at I plus plus is not equal to a hashtag, I plus plus. Well, no. Because then I can say if the data at I is equal to a end bracket, then I can return true. And then otherwise it will be return false. Pretty easy there. Okay, because this will determine if it is a inline quote unquote. It can be on separate lines, but if the ending bracket is before another hashtag, so before another token, then it is basically going to be a quote unquote inline list where it is an absolute list because you can only have an absolute list in it with no ending marker. Cool. Now is absolute, I guess, key. I think that makes the most sense because I don't really use the key language anywhere else. So then it's referring to if this is this a key? Like as in this is a key, is it absolute? All right. Yum. Okay. Yum. All right, chat. Do we game? Do I go to the gaming moment? I don't know. I think I'm buried in the software development category, which is fun. It will never bury it. Take me alive. It's still fucking hot dogs. It's still just hot dogs. It's not right. I had hot dogs for lunch. I don't want it. I don't want that again. Okay. We're gonna have to make these classes. I don't know. To make it efficient, I would. Because, make sure the base case is covered so it stops screaming. I think it's pretty good progress, for sure. Basically, to sum things up, I realize we're just writing a tokenizer for a file, which means that we have to hash our keys into tokens to make tokens, and we want to know what kind of token it is. And yeah, it's gonna be so fun. And to make this more efficient, I'll probably adjust how the data is handled in terms of like the lists, because this is kind of how it's going to have to be, because it is a tiered tree of n nodes, of like n children nodes, because you don't know how many children there might be to a node. You can't assume that it's going to be 2, so you kind of are stuck with like having dynamic lists everywhere, but you could definitely do it more efficiently by like implementing your own, okay, I want to insert a element to this list or whatever. Oh, this is an OFG list where it is only meant to hold this a maximum of like 256 elements, and now you know that that's the maximum elements you can hold, kind of thing. But yeah. It's just interesting. Go down to the M root. There we go. Right. Say I want an int depth, which is equal to 0. Well, I can say then also else if if the data at I is equal to a opening bracket and is not an absolute key, I need to change that function because it needs to know where it is. So I'll say int I. So now it knows where it is. Cool. Basically, if it's not an absolute key, then depth plus plus. And then from that, it'll be an else if data at I is equal to a ending bracket. Or I guess here I want to know if it's an ending bracket. So what I can say is ugh. Then I can basically move until the next control character. And then if the controlled character there is equal to a end bracket, then it should be that minus minus. And then if depth is not equal to 0, std error failed to get returned to root depth. Okay. Yeah. What I'll do is basically just debug by logging. Basically gonna do something like that. Just so I can see the depth. Here, I'll start at 1. Now it should always just work. Okay. What I'm assuming is happening is it's just finding not correct things. I'll make it so it's a space instead. Something like that. Yeah. Yep. Because it doesn't know that it's a separate key. Which is fine. Because it should be that's inputs. Basically right now I'm just, a lot of this is just the code that will actually do the depth maneuvering when constructing. So like I'm just not implementing the stuff that constructs it yet. That's fine. Mm-hmm. All right. Let me rerun that. Okay, so it kind of worked. Cool. So it actually kind of half worked. Now if I make it a little bit more dramatic so it's obvious to see. basically where this is where it starts to get problematic. This is not returning to the correct depth. But it got the graph, the passes, right? It then looked and found the name, and then we have the inputs. Okay, and so it realized that the inputs was a list. Then it got the name and the type, and then it got the inputs again, which was the ending bracket. And then we have the, and then it goes to the outputs. And that got through everything, and then that's where it broke at the resolution here, which is fine. And I think what I might do is I might change it so that it is a, if I make it a bracket like that, then it's a different control character. And that will be a lot easier to differentiate. Okay. I'm just trying to reorganize these rules so they're a little bit easier to read. So key always starts with the hashtag. Following character after a key is always the control character. If the character is a colon, then the data is that of which is immediately following. If the character is a opening bracket, then the following data is a list. Okay. And is within a list, then the following information composes a single element. Cool, that's easy. I should say, and the parent key or token is composed if the character is a semicolon, if the character is an opening bracket, then the following data is a list. It is assumed that a matching key with a closing bracket will end the list. I think that's pretty straightforward. Yeah. Mm-hmm. Hmm. Um, Basically, then I have to do it here for an absolute key. Yeah. Basically, if closing bracket is before, I'm just changing that. That shouldn't be there. Okay, that should now more reflect it. Because I'm just tokenizing, I'm not actually like reading the data yet. This theoretically might work. Or not, because it keeps everything to the same depth. Oh shoot, I don't know what that opened. Get out of here. Then while is not a control character. Hmm. Okay. I'll make this a found absolute list. Because now it's if data is I, which is equal to the opening bracket. Okay. Easy as that. And then else if data at I is equal to a closing bracket. Depth minus minus. Okay, so it's doing something. It goes in, and then it gets the name. Okay, so it takes the graph, takes the passes, gets the name, the inputs, and then it goes down, gets the name and the type. Whoops. All right, try and take this and compare it. So, graph, passes, and then it gets the name, and then it gets the inputs, which has a name and a type. Then it gets the outputs, okay, which then has the name, type, format, resolution, operation. And then it does that again a few times. And I got the name, the inputs. And then I got the outputs. Okay. And then I got the name, inputs, outputs. And then got the name. Inputs. A lot of inputs, outputs, a lot of outputs. Well, it's just one, but it's that one. Okay. Oh, that's right. I figured out where it screwed up. There basically was not a matching one there. There we go. Done. Because now it gets down to here, and it goes to inputs. There's no inputs, and then it goes to outputs. And then it returns back to the root. It was not returning here, which was the problem. Okay, we have depths. We can now view depths, essentially. Which is nice. Pretty cool. Cool. It's great. Mm-hmm. The funny thing I could do is possibly build not sure. Well, it does work. Like, this is generally what it needs to do. And then I just need to figure out how to put the data in correctly, which is interesting and kind of cool. I don't know what that circle means. It took 9 milliseconds to open, run, and close. Not exactly the worst. Yeah. Okay, let's try to see if we can figure out how to get data started then. I also now kind of know what a node will be, or a ref will be. It will be a constant OFG node reference m node. Because then it'll just be a view only node essentially. Okay. This is only 100 lines. So this is like this is like 150 lines, and it's already halfway through what it needs to do in terms of a tokenizer, which is pretty cool. That's kind of rad. And basically what it wants to do is I'll have the depth, and then I'll have a OFG node pointer essentially. Doesn't need to be a pointer, but it can be a pointer. Which is equal to this and at least to start. I might need to add a way to have a parent reference, but that's a future problem. Yeah. The night is getting late. I'm EP. Basically, if it's an else, then what I want to do is I want to take the node elements and place back. I'm also like hashing things a lot. And place back Does a node record one element or multiple elements? I think it's just one element. Because then I can basically make it so that it is always that the root is just kind of a null element. Yeah, I don't know why exactly. Yeah. Oh, whoops. Fuck. Okay. Element children. I guess it's more of a component. Because an element contains components, which are tokens. Components dot in place back. Basically, in place back that, then well, okay. Yeah. So I want to in place back the hash of the key. C string. Yeah. Because this one, it does a constructor. Which then I can do is I'll just do undetermined for now. Then I'll want some kind of way to output the data, so I'll just say void print and I'll just say it prints. Yeah, something like that. This means there's a new component to the list, essentially. I think I need a node parent. Yeah. Okay. Then it will be 0. Well, setup. I want this, and root, parent, children. Basically, paste back. Basically just a new child node. I'll say that front. Okay. Yeah, I know. I have to think about this. This is getting into like the actual using the data, and it's a little funky because it's not very conventional. I'll think about it. Probably come back to this Friday, or do a game and stream on Friday. Depends on how life goes. So, yeah. I think that's about all the time I have for today. I'd say it's pretty cool. Let me rebuild this. Okay. I'd say that's pretty good success. We got the graph actually understanding its own depths a little bit. Still a lot of work because we still got to control like scopes and understand scopes and stuff, but it's pretty sweet. I say it's pretty nice. So yeah, I'll thank you all for joining me. Please hit the follow button to keep up with new streams. I try to stream Monday, Tuesday, and Friday, 7 to 10 Pacific. Discord. I have a Discord server. It's in the... You click the Discord button down below. It's a little confusing. I need to change that. I haven't had time. I'm sorry about that. Click that button. It will get you to the Discord server. YouTube VODs are... If you miss anything, YouTube VODs are in the linkies down below somewhere. I forget. And yeah, hopefully I can get to starting to edit sooner than later, but school or university's got me pretty busy on time, so editing, I am not really able to edit main channel videos yet. I might be able to grind some out on spring break though, which is coming up, so we'll see about that. Thank you all for joining me. Hope you all have a good night, and yeah, see ya.